Hello, this is Brian Kaslos for Lattice Semiconductor. I'm going to show you using the Reveal hardware debugger within the Lattice Diamond 1.3 software. So let's take and open an existing design that we have. And here you can see the process list that the design has already been implemented. Now let's take a look at the file list. In the file list, the two main areas for running Reveal are the debug file folder and the programming files folder. So the programming file folder is new in Diamond 1.3. It allows you to specify the programming project to be used by the programmer tool. And in the debug file folder, you have the Reveal RVL debug projects you can take and run. If I take and open Reveal Inserter without any active projects, it takes and lists the projects it finds in the project folders and lets you select one to use. If I take and just double click on an existing project folder, the Reveal Inserter opens for that one. Or if I go and make one of these as the active one, so I'll set this as the active debug file, then just opening Reveal Inserter will open that one up. So here I've got the Reveal Inserter, which is, if you've used our previous ISP lever tool, very similar. I'll detach this so we can see a larger view of this. And in here, you have on the left the panels for your data sets. Depending if I had multiple clock regions in my design I wanted to debug, I would typically have one core per each clock region to take and be able to trace on those. I've got my design tree where I can go select signals to be used for my trace or my trigger. And I've got trigger outputs. If I've got multiple trigger cores, I can take the outputs from those and use them in other cores. So here's a list of signals that I'm tracing in the design. And here are trace options. I've got my clock, my sample clock that I can set, my trace buffer depth. I can see how many EBRs I'm using for the memory storage capture, options for how to do a single trigger or multiple triggers. And then I can do my trigger setup in terms of defining my trigger units for my different comparisons I want to do, and my trigger expressions, which will let me define the sequences I want to take a look at for my trigger units, and a variety of other different options I have here. So once I have these all set up the way I want to take and run them, I can then insert the debug into my design. I can just click here to insert the debug, and if I had multiple cores, I'd be able to select one or all of them or any number of them, and I can import this into my project and click OK. And now the debug has been inserted into the project, and I just need to make sure my design is fully implemented, and then I can take and go and program up the chip. The next step after inserting the hardware debug and implementing the design would be to program up the device. So in this case, we'll use our new programmer tool in Diamond 1.3, and I can invoke it either by double-clicking on the XCF project file or just going to the toolbar and opening programmer. So here it takes and loads the project file, and you can see that we have the device selected already. We have the programming operation. It's got the bit file to use. And from our cable selection here, we're programming it over USB. So I can simply go here and click the program icon, and this will start the programming from the XCF file I already have constructed here. If I didn't already have the XCF file, I could go and create a new one by scanning the scan chain and setting my programming options, and I'd be able to take and reuse that again. Additionally, if I have a scan chain with multiple devices here, I'd be able to use this enable toggle to be able to program a specific one on that scan chain or to program them all. So in this case, it has programmed the device. You can see the path there. So next I can open Reveal Analyzer. And when I click on the Reveal Analyzer icon, you get this dialog. I can make a new one, in which case I would specify all the different options for the port, the cable connection to the port, and which debug files to use. But in this case, I've got an existing one, and I'll change this to use this particular file, and we'll tell it to open. And now it opens up Reveal Analyzer, and let's take and expand this so we can see it better. So here's the analyzer here with the various options that I set before for my triggering. In this particular case, I want to run this trigger expression here, and my other options are okay, including I'm doing a center trigger. And this will look very familiar if you've used Reveal under ISP Lever. Once everything's all set up, I can then go over here and click the Run button, and it connects up to the device and programs up the existing debug hardware. And you can see that once it connected, it took and programmed up the device almost instantly for the debugging hardware. Now it's waiting on a trigger condition, so I'm going to go out to the hardware board, which you can't see off screen here, and reset it, and that'll cause the trigger to happen. And then you can see it immediately captures and downloads the trace data in less than a second here. So we can see from our waveform display here the various signals that were captured. And here's my trigger condition here. I can also go and drop down other cursors. So I can drop a cursor here, for example. If I want to select a cursor, I can drag it around, and you can see I get this rubber banding here, so I can measure from one event to another, and that'll move the cursor around. I can also go here and right click and say add another cursor, and then I can drag that cursor around to where I want that to be. I can go to my zoom mode and select a region and zoom in on it whenever I wish. Pan mode again, you can see that we can pan data from side to side. And so I can use the data in the waveform window here to view the data, to zoom in, the various triggers. I can also take and do changes here on an individual signal. I can set the bus radix. I can set the clock period so that each one of these sample clocks can give an actual time delay to it. And I can do things like export the waveform. And I can take this waveform data and I can export it either in VCD format or in a text listing. So that's an overview of using the Reveal hardware debugger inside of Lattice Diamond 1.3, which includes now integration with the new programmer tool in Lattice Diamond 1.3 and some significantly increased speed ups with the cable connection that allow you to both program the device within a couple seconds and download the data within a second or so.